Hello, geometry students, and welcome back to another video lesson as we start to explore something called trigonometry. That dreaded trigonometry word. So, we're going to learn what the three trigonometry functions are, how we find them, and eventually what they are going to be used for. This topic will pretty much cover the whole week. Lots of different practice and getting ready and how to use them. Today is the introduction to what it represents. So take good notes and reach out if you have questions. Trigonometry and what we might call trig ratios, okay? Trigonometry is the study of the relationship between the sides of a right triangle and the angles that are in that right triangle. It's the study of the relationship or the ratio. What do you know about the word ratio? Typically, sometimes it's like 3 to 5. We write it with a colon. Or we could write it as a fraction, 3 to 5. And we're going to use a lot of fractions like this in trigonometry. Okay. The first thing you need to know about trigonometry is every side on the triangle has a name, a very specific name. We already know the name opposite the right angle. Okay. This is always going to be the hypotenuse if it's opposite the right angle. It's that hypotenuse. Now, the other two are going to be called opposite, or the opposite leg, and the adjacent leg. The opposite and the adjacent. Adjacent means it's next to it. Kind of like your next door neighbor. They live adjacent to you. Adjacent. Now, the tricky part with that, and I'm going to try and draw these in two colors, is that it depends on which angle we're using in the triangle. If I were to use this angle up here as A, the side right next to angle A would be called the adjacent, or ADJ, adjacent, and then the side all the way across from it would be called the opposite, or what we call OPP, op. Okay, but that's because I was standing here at A. If for some reason I changed my mind and said, you know what, we want to use this angle down here, angle C, all of a sudden this side next to it becomes the adjacent, and the one all the way across from C would become the opposite. And we use these three, adjacent, opposite, and hypotenuse, for our trig ratios, but it all depends on where we are at in the triangle, which angle we are using, and which one becomes the opposite and the adjacent, okay? And that's what's really, really, really important, okay? We have to understand that. The second part comes from what are called the trig ratios, the trigonometry ratios, the fractions that we can use. And the first one is called sine. On your calculator, it looks like the word sin, but it is sine. And the relationship for sine, the ratio, is that we take the opposite side of where we're at and put it over the hypotenuse. The opposite leg of the triangle over the hypotenuse. It just depends on where we're standing. Okay. Cosine, often called cos, C-O-S. The cosine ratio, this trig ratio for cosine, is the adjacent over the hypotenuse. Whatever the adjacent side is over the hypotenuse. And again, we have to figure out where we're at. Which angle in the triangle are we at? And then tangent, that's also called tan on a calculator. But the tangent of a circle is going to compare two different sides. This will be the opposite over the adjacent, depending on where we are in the triangle, which angle we are using. Now, you may have heard the following phrase before. It's called I gotta undo that. Hold on. SOHCAHTOA. SOHCAHTOA. So the sine equals the opposite over the hypotenuse. Cosine equals adjacent over the hypotenuse. And TOA, tangent equals opposite over adjacent. They're just abbreviations or acronyms that help us maybe remember these. But I would make sure that you have these written down somewhere because we're going to use them on the next 2 slides. So here's an example. All right. Here's an example. I've got this triangle, ABC, which is a right triangle, and I've got some sides labeled 3, 4, and 5. The first question is, what is the sine of A? The sine of A. Well, if we remember, the sine, S-O-H, so katoa. So sine is the opposite over the hypotenuse. Opposite over hypotenuse. But we have to look back over here to figure out which angle are we standing at. So for this example, we're standing at A, which means the one across from it is the opposite. The one right next to angle A is the adjacent. And the one across from our right angle is the hypotenuse, because we're standing at A, angle A. Sine uses the opposite side, so 4 over the hypotenuse, 5, 4/5. Opposite over hypotenuse. What do you think the cosine of A is? The cosine, or ka. Cosine is the adjacent side. So here's A. The adjacent side is 3 over the hypotenuse, AH, over the hypotenuse, which is 5. So the cosine of angle A is 3/5. The tangent of A, TOA, T-O-A, TOA. We're still at A, so we can leave those as we've labeled them. O over A, opposite over adjacent, which is 4/3. Now, we don't have to simplify or reduce them. I mean, we should reduce them. We don't have to turn it into a mixed fraction. All right? So that was for the A's. What happens, though, if I ask you to find the sine of B, the cosine of B, and the tangent of B? Well, now, all of a sudden, we're not over here using this. Oops, I don't want to erase that whole triangle. Right? I'm not at A. I'm going to be up here at B, which means this isn't the opposite anymore. And this one's not the adjacent anymore. Okay? If we were standing at B, and let me fix my triangle that I wrecked. Okay, close enough. Now we're standing up here at B, which means the side next to it is now going to become the adjacent, and the side across or opposite becomes opposite. All right, so what is the sine of B? The sine of B. Well, sine is opposite over hypotenuse. So the opposite of B is 3 over the hypotenuse, which is 5. What is the cosine of B? Well, cosine, ka, is the adjacent over the hypotenuse. The adjacent to B is 4, and the hypotenuse is 5, 4/5. What is the tangent of B? TOA is the opposite over the adjacent, or 3/4. So really, it all depends on which angle they're telling us to use. We need to figure out which angle, because that angle is then telling us how to set up the triangle, either adjacent and opposite. All right, here's one more example. Now, instead of using letters, they're going to also use angle measures or a number. Find the following: the sine of 30 degrees. The sine of 30. Well, nice that the 30 is labeled here. And remember that the sine is the opposite over hypotenuse. What's opposite the 30? That would be 1. And what's the hypotenuse of this triangle? Across from the right angle is 2. So the sine of 30 in this triangle is 1/2. What's the cosine of 30? Cosine is CAH, or Ca, which means the adjacent over the hypotenuse. So if I'm at 30, which one's the adjacent? The square root of 3 over the 2, the hypotenuse. All right, so it's all because we were standing at this 30. Now, what about the tangent of 30? TOA, T-O-A. The opposite side, which is 1, over the adjacent side, which is the square root of 3. Uh-oh. We're not allowed to leave these radicals down here. So we've got to change this by rationalizing this denominator and multiplying by the square root of 3 over the square root of 3, which gives me square root 3 on top over the square root of 9, which really on the bottom is 3. 3 square roots of 3 for the tangent of 30. Now, what about the last one, the cosine of 60? The cosine of 60. Why don't you take a guess? Okay, 60. Well, it's not in that triangle, Mr. G. I'm stuck. Well, remember, all triangles head up to 180. If this is 90 and this is 30, that's 120, which means this one has to be 60. 60. And cosine uses the adjacent and the hypotenuse. What is adjacent to 60? That's the 1. And what's the hypotenuse of this triangle? 2, which is 1/2. So that's how you're going to have to use those trig ratios, sine, cosine, and tangent, to find the ratio between the sides, all mattering about what angle you're using and at. If you have any questions, please make sure that you reach out. Otherwise, until next time, everyone, stay safe.